Hello, thank you for joining today's webinar. Today's webinar is talking about CyberSense. CyberSense as the last line of defense against ransomware. My name is Jim McGann. I'm Vice President of Marketing at Index Engines. I will be taking you through the presentation today. If you do have questions, we're going to keep it short at 30 minutes today. I know everybody's got a lot of stuff going on. But if you do have questions, either shoot an email. My email address is there. I'll put it up at the end of the session. Or you can type in the chat area and we'll try to take the question during the session today. Index Engines, for those of you not familiar with us, we're a software company. We're located in the United States in New Jersey. It's a software platform that was built to support a number of different use cases, from data management, data analysis, to data governance. Today, we're really focused on the data analysis, which is really contains our CyberSense capabilities. We have clients, we've been in business since 2014, so many years. We have hundreds of clients globally in all sorts of different industries. And one of our key partnerships is with Dell EMC and their Cyber Recovery Vault, which I'll talk about today. We're also included in the IBM Resiliency Services offering. We're partnered with AWS and a number of global system integrators across the globe. Ransomware is one of the hotter topics these days, especially in today's COVID timeframe, where the ransomware and the cyber criminals aren't taking the day off. They are working from home, but they're as active as ever. It's important to understand what CyberSense is, but it's also not what it isn't. It's not a replacement for real-time security solutions. So when we talk to clients, they say, well, I've got 75 different security applications running, from behavioral analytics like Varonis to real-time protection from McAfee or Symantec or other tools. We know for a fact that cyber attacks circumvent these tools and get into the data center. They're not 100% effective. If they were 100% effective, cyber criminals wouldn't be as successful as they are. What CyberSense is the last line of defense. It's looking for signs of data corruption. So types of corruption that occurs is typically encryption, encryption of a file, encryption of a page of a database, data corruption, changing file extensions, ripping out content in files, and deletion, mass deletion of file. What cyber criminals are doing is basically the same thing over and over again. We know that for a fact. So what CyberSense does as the last line of defense is looks for those types of attacks, look for those types of corruption. And when that type of corruption is detected, it'll send an alert. So the obvious place for CyberSense is integrating it with the backup software. So as backups occur, in the case of the Dell EMC product, into an isolated vault, CyberSense will look at those backups, determine if there's signs of an attack, and send an alert out. So as I mentioned, backup, that's core to what CyberSense supports, is to be able to index backup images. So there's a lot of technology that we've developed over the years to be able to directly index the contents in backup images. An important point is it's not just looking at the integrity of the backup image, it's looking at the content and the files and the data and the databases inside backup images. So an important page on our website, as you can see here, as you can see down below, I'll highlight it, is indexengines.com/CS for CyberSense. This is where the current support matrix is posted. And it shows you the type of backup applications that we support today. So today we support Dell EMC from Avamar Networker. PowerProtect Data Manager is coming soon. IBM Spectrum Protect, Commvault, and Veritas Net Backup. It also depends on the backup clients. So there's a very detailed support matrix here that'll show you what we're working on and what is currently supported today. So the fact that CyberSense can get inside these backup images and look at the content, examine the integrity of files and databases is core to the capability, and actually the most unique capability that's really available only with CyberSense. So with the Dell EMC Cyber Recovery Vault, which is our core implementation, we know that the isolated vault is isolating and protecting assets. What CyberSense does is once the data is isolated and protected, directly scans the backup images that are populated into the vault and looks inside the data. So in the baseline scan, so day one that you populate the vault, CyberSense will create an initial observation. CyberSense gets its value and its reliability from looking at observations of the data, looking at how data changes over time. So if you think as a backup of data as an observation, on day one with a single observation, CyberSense has 95% confidence in finding corruption. So it's going to find the obvious types of corruption, you know, file extension mismatch, encrypted data, and so on. But where CyberSense gets smarter, up to 99.5% level of confidence in finding corruption, is comparing data as it changes over time. So when a Word document on Tuesday had a certain size, had a certain extension, was not encrypted, then on Wednesday it was encrypted, the extension changed to .lol or .encrypted, and the size changed dramatically. That's obviously an attack that on that Word document. So it's comparing observations of the data. So those are the two key capabilities that CyberSense provides with cyber recovery. The third is forensic reporting. So if and when your customer does get attacked, CyberSense provides a number of reports to be able to look at the data and analyze exactly what's going on with the data to be able to recover very quickly. That's key to really, you know, showing off the capabilities to be able to recover in hours and days, not weeks and months. And we'll talk about all these capabilities as we go through the session. So the workflow is very straightforward. And again, this is integrated with the Cyber Recovery Vault, so the automation is there. The scan occurs, scans backup images directly, looks inside every file, every database. There's over 100 analytics that are generated, the analytics that are indicative of a cyber attack. So we look for something that we call file entropy. Entropy is the random disorderness of a file. So when a file becomes encrypted, the entropy score increases. We have an entropy score from 0 to 100. When the entropy score of any file or any page of a database goes to 99, that signifies encryption. We also look for mass deletions, mass creations, file type mismatch. So by reading the header of the file, saying, does the header says this is a PDF? Is the extension a PDF extension? So for example, if a Word doc on Tuesday had an extension of .doc and an entropy score of 45, that's typically normal. On Wednesday, if the entropy score goes to 99, that signifies that it was encrypted. A user could have encrypted it or put it in a zip file or a folder. But if at the same time, the analytics shows that the extension changed from .doc to .lol or .encrypted, that's an attack vector. So all these analytics are generated and fed up to machine learning algorithms. The machine learning algorithms have been trained on thousands of Trojans and all the common attack vectors that exist out there. So with the machine learning, that automates the process of looking at the analytics as pieces of evidence. And if the evidence basically points to an attack vector, that's when it's going to send an alert. If the analytics don't show any type of a common attack vector, that process will not send an alert. And that process will repeat over and over. So the beauty of integrating this with the isolated vault is the data that's isolated in the Dell EMC Cyber Recovery Vault is checked and validated. And if there's no alert generated, the customer has confidence that that data is a good copy. And if they do get attacked, they can restore that right away without having to validate the integrity of that data. If there is a red alert or an alert on the data, there's a bunch of forensic reports that allow you to quickly diagnose and recover and find the last good backup set instead of having to do the whole forensic analysis. So that's a standard workflow. This is integrated again with cyber recovery. This is the cyber recovery vault environment. So just to quickly show you how that works, you got your production network. You've got a data domain over here in production that's doing your production backups. The cyber recovery vault here on the right is an isolated vault. So it's air gapped off the network. So in a unpublished IP address so that hackers can't even understand that it exists, that sync is automated. So when the schedule is set and the sync occurs, the data domains communicate with each other and open up the port, replicate the data into the isolated vault, apply retention lock so the data is locked down and can't be modified. Once that is done, then CyberSense is notified that the data is in the vault, it's locked down. The data domain in the vault presents a shadow copy of the data for scanning. That shadow copy is used for indexing to create the analytics and then tossed aside. And then the analytics are fed to the machine learning, and the results of the scan are presented to the cyber recovery dashboard as either an alert or no alert required. Straightforward process. If there is a red alert process, so if there is a red alert and CyberSense say, hey, there is signs of corruption that's occurring here, what CyberSense does is a number of different things. It'll let you know when it happens. So many customers have slow attacks that occur over time that they're not even aware that data is being corrupted. There's been attacks that happen over many months, and the customer is just very much in the dark about what's occurring. So with CyberSense, you'll know with that current backup of data that, hey, this backup looks like there's suspicious data that's happening here. The important point here with CyberSense, it'll give you the who, what, where, and when of what's happened. You know, who was impacted, how much damage was done. Was it 5 files that were corrupt or 50,000 files that were corrupt? What's the extent of it? What was attacked? You know, what specific files? Maybe they were just files in the human resources department or the finance department, maybe files on a specific server. With CyberSense, you'll also get a full listing of the file name and the path of the files that were corrupted. So you can use the event log analysis capability to look at the source. So which user account last modified or last touched these files. So if 1,000 files were corrupted or encrypted, which user touched those files last? If they're all the John Doe user account, that's the account that was breached on the network. You could also query the event logs to say, well, which executable was used to do the encryption on those 1,000 files that were encrypted. That would be your actual ransomware. So CyberSense wasn't necessarily designed to find the ransomware, but it finds all the evidence and the end result of what the ransomware did. And by using some of these capabilities, you could backtrack and look at the evidence and say, hey, who was the user doing this encryption, corruption, and what executable? And that'll give you all the details you need to really understand what's happening there. And then when did it happen? Where are the last good backup sets? So the beauty of this is, you know, if you do have an attack without CyberSense, you need to validate the integrity of the data before you start doing restores. CyberSense will be doing that on an ongoing basis. So that's a very important point. If this is happening on an ongoing daily basis with all your current backups, you'll have the confidence that the backups have integrity. And then when you do get attacked, your customer gets attacked, you can go to CyberSense and say, where are the last good backup sets? And maybe a number of backup sets that span a number of different days and times. And CyberSense will give you that list. Those simply need to be restored in production, and you will minimize downtime. So as I mentioned earlier, the workflow, post-attack workflow is straightforward. There's the comprehensive indexing that occurs over time. We talked about that already. There's over 100 security analytics that are generated that are indicative of the cyber attack. We spoke about that as well. And then the machine learning will tell you a deterministic, yes or no if the data looks like it's gone through some type of corruption. So again, it's been trained on thousands of Trojans and over 20 attack vectors. So, a common question here is, do I need to update CyberSense continually every time I do a scan? CyberSense is not like the typical real-time scanning solutions that are signature-based that need to update the signatures every time. CyberSense is looking for signs, signs of data corruption due to a cyber attack. And what the cyber criminals are doing does not change that much. They're successful. They've had great success. They change continually how they get into the data center and how they attack the data center and penetrate it. But once they're inside, the actual corruption is similar over time. It's been similar for the past few years. So CyberSense looks for that type of corruption. So you don't necessarily need to update CyberSense continually. It's a good idea to do that. But if you don't update CyberSense, you'll still have an effective scan. So the first step is attack vector notification. So if CyberSense does see some type of attack, it'll notify with an attack vector, and I'll talk more about that as well. It'll also, as I mentioned, give you the full listing of corrupt files. So the detailed listing, the full file name, the full path of the file, and so on. So you could use that information to see where the attacks occur, what's the extent of the attack, how many files were corrupted, and so on. Again, using the event log, so CyberSense does have event log reporting. In the case of using the Dell EMC Cyber Recovery Vault, if you do put the event logs in the vault, Some customers are doing that. A lot of customers are not doing that because it's a lot of data, and it changes very, very frequently. If you use other event log tools to be able to search the event logs, you can upload the list of corrupted files, whether it be 10 files or thousands of files, and say which user touched those files last, and then which executable was used to make a modification on that file, whether it be corruption or a deletion or so on. That will give you the detail of the breached user account. It'll also give you the detail of the location of your ransomware. And then finally, as I mentioned, CyberSense will give you the actual backup set ID, the backup set time of the last good version of the file. So that would be your recovery process. So if you're creating a runbook here for your clients, this is critical to, if you do get a red alert, let's get the listing of corrupt files, find the extent of it, let's analyze the event logs, and let's get the backup sets immediately to understand how to recover quickly. So it's a pretty straightforward step-by-step process to recover, from an attack and minimize downtime. So this is the Cyber Recovery Vault with Dell EMC. You can see this is their dashboard. The CyberSense alert is integrated with the dashboard. So you can see here this red alert. It's a little bit hard to read. This is saying that there's suspicious file activity going on, and you see the critical alert. So a typical customer environment or a Vault environment, looking at this dashboard on a daily basis is part of the daily routine. And what we see from customers is they like the automation. They like that it's, set it and forget it type environment. They can come in and check this and say, hey, no critical alerts here. Everything is good. Go on about your daily business. If there is a critical alert, that's when you need to kick into a runbook or a post-attack process. So here we're showing you the critical alert. CyberSense, as I mentioned, generates over 100 analytics. This is not important for customers to look at. This is just giving you some of the inside information about CyberSense and what it's doing. As I mentioned, these analytics look for things like, file similarity, dissimilarity, deletion, creation, file corruption, file extension mismatch, entropy, as I mentioned, which signifies file encryption. So it's looking for entropy threshold on the entire data set. It's looking for change file count. So, what we want to do is minimize false positives and false negatives here, right? So the analytics are really the pieces of evidence that are of what happened to this backup set. So it creates these pieces of evidence, compares it to the previous backup set and how data has changed, and then uses the machine learning really to minimize false positives and false negatives by saying, hey, this machine learning has been trained on common attack vectors. Give me all the evidence, and as a machine learning algorithm, I'll figure it out what's happened here. So in this case, the machine learning has kicked out that this is attack vector number 6 that's being executed here. So based on how the data is changing on this new backup, it looks like it's attack vector 6. CyberSense monitors over about 28 different attack vectors. The top 6 highlighted in red are the dominant ones. They're over 99% of what's happening out there today. It's mostly about encryption and changing file extensions. That's 99+% of what the cyber criminals are doing, although CyberSense looks for a number of different types of attack vectors. So here in this attack vector number 6 was strong encryption. So it encrypted a file, a Word document, a PDF, an Excel spreadsheet, could be a page in a database, and then obfuscated a file name. So, it could append onto the file name a .lol, .encrypted, whatever. So it manipulated the file name of the file. So that's the attack vector that CyberSense and the machine learning picked up. So let's go further into the post-attack reporting capability to see what's happening here. So in CyberSense, you can run these reports. This is the CyberSense interface here. And this report is interesting because what CyberSense does is it tags the last good file. So if it does see file corruption, it'll auto tag the last good versions of the file, and then also tag the suspect corrupt files. So it makes it easy for you. You can run these reports, and these are running the reports on the tags, saying, show me the original files. These are the last good ones, and show me the suspect corrupt files. So you can compare them side by side. And if you look here in this report, so we ran the report and put them side by side, you're seeing on the bottom here, the 0001.doc, that's the last good version of that file. So you can see CyberSense has tasted it or detected it's a Word document. The file name looks fine. Above it is the corrupted version or the post-attack version. So you can see the Word icon is gone, so CyberSense can't even detect that it's a Word document any longer, so the file has been corrupted. And the file name has an appended .fun extension on the file. .fun is an interesting extension because it's a valid application extension. So if you're just looking at metadata, you may say, hey, .fun, that's a file extension that's typical and normal, so that should be good. But here CyberSense is looking at that saying, hey, that's a .fun extension and I can't read the file. There's a number of pieces of evidence here that point to some type of corruption, which I'll go into further. So looking at that further, here I'm looking above, you see highlighted in that orange there, I'm looking at the metadata of that corrupt file. You don't need to examine every file here. I'm just taking you deeper into CyberSense reporting. And here it says CyberSense's file type. This is now unknown. So the previous version would be a Word document, that's obvious. So CyberSense can't detect what it is any longer. And also the file entropy, as I mentioned, entropy is the signifies encryption. And when it gets to 99, a score of 99, that means that it's an encryption due to a cyber attack. So the pieces of evidence here based on the analytics is that this file has become encrypted and it's been corrupted so much that it can't even be read. So let me go back one. So that basically is all the pieces of evidence about that file that the machine learning would be used to say, hey, it looks like attack vector 6 is being executed here, and I can get you the listing of corrupt files. So this is probably the most important report here, and this is kind of a couple different reports. But on the upper left here, you can run a report in CyberSense and say, show me the last good version of all the files that exist. Now, you know in a typical backup process that these files could be on different backup sets that were run over different days. So this is where the time occurs in recovery from a cyber attack. So when we examine a number of cyber attacks that occur, and even though on day one they know the attack vector, they know what type of ransomware is being used and so on, what they spend 3, 4, 5, 6 months or longer doing is going through the old backups and trying to find the good backup sets. So by running CyberSense in this environment, CyberSense is understanding where the good backup sets are. So saying, hey, here's a few thousand of the files that were corrupted, and here's the last good version of these files. CyberSense has an automated report that'll say, hey, of these 1,000 files that were corrupted, show me the last good backup sets that these files existed on. So on these dates, and you can see these different dates and times, these are the 9 different backup sets that need to be restored in production in order to replace the corrupted files with the last good version of the files. So if I was working with a customer that got attacked, I would immediately run this report, find these backup sets here, and say, get these backup sets, from offsite or wherever, from the replicated backup environment, and put them back into production as soon as possible. And that takes, weeks and months of downtime and turns it into hours that you can restore. It's basically as long as you can, as long as it takes to restore these backups. So it really simplifies the process significantly. So that's about it for today. If you do have questions, type in there, or I'll put up the email address at the end. But again, the differentiation of CyberSense, again, it is very unique. It is very different in the market. A lot of our partners that have done due diligence on other capabilities that exist out there find that there's nothing like this as doing full content-based analytics at this level. It's not a replacement for real-time security. Some customers get confused about that and say, are you asking me to replace my McAfee or Symantec or Varonis products or whatever they may be using? No, it's not the case. This is a last line of defense. It's assuming that those products are going to be circumvented, and CyberSense would look for signs of corruption. This is the only solution that looks inside files and databases for corruption. It's looking inside every file and every database, and customers are amazed that it can do that, within a time frame of the hours that it takes. So in an isolated vault, if you're putting in 50 terabytes or 100 terabytes, you run the servers in there, and the servers are busy processing data continually, just looking inside every file and every database. It's not a simple light scan. This is a very intensive scan to make sure that the data is clean and signs of corruption are not there. And the main point is that the cyber criminals are getting a lot more sophisticated. They're not just attacking metadata. They're not just looking at a very simple types of attacks. They're going deep inside the content to corrupt the data. And they're using machine learning. So if cyber criminals are getting more sophisticated and using machine learning, you and your customers should as well. And that's really where CyberSense fits in. So we're really towards the end of our half hour, so I'm happy to keep it nice and short today. If you want additional information, go to our website, indexengines.com/cybersense, or link on the homepage to the CyberSense page. And there's a number of additional materials from white papers and data sheets and all sorts of material on there. Again, if you send an email to info@indexengines.com, we have a team of folks that are working with the Dell EMC team and the other system integration partners out there today, providing all sorts of technical resources and technical support help out there. So if you do have questions, feel free to reach out to us and we'll get you any kind of information you need, any kind of sizing or support or technical information or presentations or demonstrations that are required. So that's it. Thank you for your time today. Really appreciate it. I hope you found it useful, and we look forward to speaking with you in the near future. Thank you and have a good day.